Hi everyone, welcome to Rodha. My name is Apurv, and you guys have already been introduced to me. In today's video, we'll be discussing a wonderful set. It's a set which is not a very complicated one, seems like a easy one, right? But it's a moderate difficulty level set which can really get you, incorrect answers in the exam scenario. It's a set where you might make a lot of silly mistakes, right? And it's a set which involves a bit of maximizing, minimizing things, and it's basically a logic based DI. So it's a combination of LR as well as DI, right? So I would want you guys to pause this particular video, try the sets, right? Try this particular set here, and then maybe proceed ahead with the solutions. For our, for my information, you can even, comment the number of questions that you got correct in this particular set out of the set of whatever 4 to 5 questions we have in this particular set, right? So it will be really great for me to know that, how are you guys performing in the difficulty in this level of difficulty, right? And if I find that most of you are getting a really high accuracy, then maybe we can further increase the level of sets or maybe tone down the level of sets. So we just want to go with the audience here, how the audience is doing, right? And how they are finding the sets. And we'll keep on, uh, d- keep a balance between easy, a medium, and a difficult set, right? Because cat is also like that. In the 4 sets that you get in a particular slot, if I say that, the pattern remains the same, then one of the set would be difficult, two of them would be of one easy to moderate, one moderate to difficult. So that is how cat is, and that is how we are also gonna maintain the flow of LRDI practice sessions here, right? All right, so let's just start with this particular set here. It says a railway reservation counter in Andheri West has 5 counters numbered from 1 through 5. The table below gives the total number of transactions in the 5 counters in various time slots S1 to S6 in a certain week. All right. So the counters are open from Monday to Sunday, right? There are different time slots, 8 a.m. to 10 a.m., then 10 to 12, 12 to 2, 2 to 4, and so on and so forth. And these values here, right? These values here is sum of all the transaction across the 5 counters. For example, I can say the number of transaction across counters 1, 2, plus 3, plus 4, plus 5 on Monday in the slot 8 a.m. to 10 a.m. is nothing but I can say 64. So this gives you the total. It does not give you the individual counters, right? It gives you the total. I'm hoping they don't ask me to figure out, the number of transaction at each counter at each of these slots, right? Because that's gonna be a very tedious job. But let's see how the set goes. So I hope you guys have understood how the table looks like. You have days on one side, you have slots on one side, and you have this values here, right? Now it's highly likely. Now this makes my life a little easier, right? Now, the cat, they can increase the difficulty level of this thing by giving you cumulative data. Let's say they give you from 8 a.m. to 10 a.m. The number of transaction is 64, and then they tell you, okay, 8 to 12, the total transaction is the sum of two. They can give you the value, right? They can say that it's 136, right? So you have to subtract 64 from 136 and get 72 and so on and so forth. And they can even give you in the form of the bar graph. Let's say this is here, in the next 4 hours it reaches here. So the complexity of the set, the time that has to be invested in a set can be increased, right? So it's just that LRDI is all about getting the idea of the concepts. If you're comfortable with the concepts, if you are familiar with all the varieties of sets, then it is a cakewalk for you, this particular section here, right? And we at Rodha, we already have over 500 sets here, and we will be covering a lot of sets going forward, right? So what our target is that we introduce our students to all the possible varieties that exist, so that when you're sitting for the CAT exam, you don't find anything new there, right? All right. Let's continue with the discussion here. So it says that it is known that on Monday, Wednesday, Saturday, and Sunday, the staff managing the odd number counters take break from 1 p.m. to 1:30 p.m. All right. So the staff managing the odd number counters, that is 1, 3, and 5, they have their break from 1 to 1:30 p.m., right? And while the remaining staff take their breaks from 1:45 to 2:15. All right. So the counter number 2 and 4, they take their break from, I can say, 1:45 to 2:15 p.m., right? Now, further it says, And on the rest of the days, the staff swap their lunch slots. Okay, so this information is for Monday, Wednesday, Saturday, and Sunday, right? Rest of the days remain as Tuesday, Thursday, and Friday. Now, on these particular days, they are swapping, right? So I can say 1, 3, and 5 is gonna take their break from 1:45 to 2:15, right? And 2 and 4 are gonna take their break from 1 to 1:30, right? So counter number 2 and 4 are gonna take the break from 1 to 1:30. All right. Now let's see it further. It says normal transaction hours are from 8 a.m. to 8 p.m. excluding lunch breaks. So lunch breaks is excluded here, okay? And rest everything is a transaction time, right? The ideal time for a slot is defined as the sum of ideal periods, that is the duration for which no transaction takes place during the normal transaction hours. All right. So if there's no transaction that is taking place during the transaction hours, that is excluding the lunch break, then it is called as the ideal period. All right. At all the counters open during that slot. So that is the ideal period across all the counters open during that particular slot. Okay. Any time lag between two successive transactions other than that due to scheduled lunch breaks may be ignored. All right. So anything apart from lunch break is a transaction hour across the entire day if the slot is open, right? If the counter is open, right? Now, assume that all the counters are open during all the normal transactions are until mentioned otherwise. So we are assuming that all the counters are open from 8 a.m. to 8 p.m. Except if it is mentioned explicitly that it has been closed. All right. All right, so there's not a lot of information here. I don't have to decode a lot of things. I think it's a question wise set. Yes, seems like a question wise set. Okay, let's just start with the first question here, or maybe I'll just run through all the questions and you know so that you guys can solve, because I want you to pause the video and solve this particular set, right? So I'll just run through the questions. So first question is, if on Monday at each of the counters the average time in slot 1 is 6 minutes and the ratio of the number of transactions at counter 1, 2, 3, 4 is this much. Okay, find the number of transactions done at counter 5. Okay, so this is your question number 2. We'll come to this one by one. You guys can pause the video and take a screenshot of the question and can attempt, right? So this is question number 3 and this is your question number 4. All right, so it's a 4 question set. Let's just start with the first one now, right? Now it says, if on Monday at each of the counters, the average time for a single transaction is slot 1 is 6 minutes. All right. And the ratio of number of transactions at counter 1, 2, 3, and 4 is 3 is to 2 is to 5 is to 1. Find the maximum number of transactions done at counter number 5. All right. So let us say that, transactions done at counter 1 is to 2 is to 3 is to 4. This ratio has been given to me as 3 is to 2 is to 5 is to 1, right? So let's say this is nothing but 3K, 2K, right? 5K and a K. So these are my number of transactions done at the 4 counters, right? Let's say counter number 5, the number of transactions done is X, right? Now it says here the average time for a single transaction is 6 minutes, right? So in slot 1, how much time is there? Can I say there's a time of 8 a.m. to 10 a.m., right? Which is exactly 2 hours, right? So slot 1 has a time of, can I say 2 hours, which is same as I can say 120 minutes, right? And for one transaction, the time is 6 minutes, right? On an average. So can I say the maximum number of transactions that can occur is nothing but 120 by 6, that is 20 transactions, right? That is basically 20 transactions. All right. Now if 20 transactions can occur, right? So at counter 1 the number of transactions are 3K, right? So can I say 3K should be less than equal to 20, right? Similarly 2K should be also less than equal to 20, right? 5K should also be nothing but less than equal to 20, and K should also be nothing but less than equal to 20. So from here I'll be getting different values of K here. So from here I'll get K should be less than equal to 20 by 3, that is 6 point something. I'm not getting to the exact figures. This is K should be less than uh I can say 20 by 2, that is 10 here, and here K should be less than equal to nothing but I can say 4 here, right? And here the K should be less than equal to nothing but I can say 20 itself, right? So these are the values of K here, right? Now it says find the minimum number of transactions done at counter number 5. All right. So the minimum number of transactions that can be done at counter number 5. Let's see. So if I have these 4 transactions here, right? So can I say 3K plus 2K plus 5K plus X? This should give me the total number of transactions slot 1 across the 5 counters. And if you go back to the table, the total number of transactions slot 1 across the 5 counters on Monday is nothing but 64, right? Because the question talks about Monday, right? So this value is 64 here, right? So I can say that 11K plus X is equal to 64, right? So from here I can say 11K minus 64, or I can say 64 minus 11K should be equal to X, right? So I can say X should be equal to 64 minus 11K, right? Now, if you want to maximize the X, right? Because the question says find the minimum. Okay, I want to find the minimum number of transactions done at the counter number 5. So if I want to minimize this, right? If I want to minimize this, then can I say I should try to maximize this? Isn't it? And if I'm trying to maximize this, so what is the maximum possible value of K that I can take here, right? So the maximum, can I take K as 10? No, not possible. Can I take K as 6? No, not possible, right? Because it will come out to be negative, which is not possible, right? Can I take the value of K as K is less than equal to 4, right? So can I say the maximum value of K, because understand here, from all these inequalities, any value of K should satisfy all the inequalities, right? So if I see here the 4 inequalities here, right? If I look at the common solution, so can I say that my K should be less than equal to 4, right? Why? Because the value of K, whatever I take, should satisfy all these inequalities. If I take K as 5, then it is gonna satisfy, I would say, this particular inequality, this one also, and this one also, but it will not satisfy this inequality, because as per this inequality the value of K should be less than equal to 4, isn't it? So I should look for a range which satisfies all the 4 inequalities, and that is nothing but K should be less than equal to 4. So if I want to minimize X, right, so I should maximize K, and the maximum value of K from here is nothing but 4. So I can say if I substitute K here as 4, so I'll get X is equal to 64 minus 11 into 4, which is 44. That gives me nothing but 20, right? So that should be my required answer, right? Now, if by any chance, you guys get confused with this inequality thing here, so I would suggest the best way, the best way to do this is you can always take a help of a number line, right? So you can always take a help of a number line, something like this. For example, the values of K, if you see here, were nothing but less than 10, less than 20, less than 6, and less than 4, right? So if I take one point as, let's say, 20, okay? So this is 20 on the number line. So can I say my K should be less than this? That is, it should be to the left of this, right? Then I can say if K is less than 10, so this point here is 10. So I can say my K should be to the left of this also, isn't it? Then if I say K should be less than 6 point something, so let's say 6 point something is somewhere here, right? So I can say my K should be less than this also, right? And if K is less than 4, less than equal to 4, right? So I can say my K should be to the left of this also. So which is the region in which I'm getting all the 4 color lines? Can I say this is my required region in which I'm getting all the 4 color lines, right? To the left of this, I'm getting all the 4 colored lines, isn't it? Yes or no? That is red, pink, green, and white. So that should be my required range of K. So if that is my required range of K, so I can say that is why I mentioned here that K should be less than equal to 4. So whenever you're confused in inequality, please make sure that you're taking a help of a number line here. All right, let's move ahead to the next question now. It says on Friday, 2 staff members scheduled to manage. Okay, this is manage. Counter number 4 and 5 were on leave, and hence only counter 1, 2, and 3 were open to the public. All right. So on Friday, because 2 staff members scheduled to manage counter 4 and 5 were on leave, so only 1, 2, 3 is open. Okay, so on Friday, only counter number 1, counter number 2, and counter number 3 is open, right? Okay, further it says the time taken for each transaction in counter number 1, 2, and 3 is 3, 2, and 1 respectively. All right, so counter number 1 takes 3 minutes for a transaction. Okay, counter number 2 takes 2 minutes for a transaction, and counter number 3 takes exactly 1 minute for the transaction. Okay, and the transaction, each of the counters began at 8 a.m. Perfect. If at any instant there is more than one counter free, and available for a transaction, then the transaction is carried out at the counter, which takes the minimum time for the transaction. All right. So if at any instant, if more than one of the counter is free, right? For example, let's say a transaction comes in and both counter 2 and counter 3 are free. So because counter 3 takes 1 minute and counter 2 takes 2 minutes, so the transaction would go through counter number 3 because it says it will go through the counter which takes the minimum time. In which counter does the 74 transaction for the day take place? Assume that all the people who come to transact stand in a single queue, and at that time no and that at no time the queue is empty. All right, so there are 74 people. So in which counter should the 74 transaction take place? All right, perfect. So understand here. Now the very first transaction that comes in at 8 a.m. should go to counter number 1. So transaction 1 will be occurring at counter number 3, right? Because it takes exactly 1 minute, isn't it? And at the same time, can I say transaction 2 and 3 are also ready because it says that at no time the queue is empty, right? At no time the queue is empty. So can I say transaction 2 should start from counter number 2 and transaction 3 should start from counter number 3, right? Now, at the end of 1 minute, what will happen? Counter 3 will get empty. So transaction number 4 can be started at counter number 3, right? So at the end of 2 minutes, what is gonna happen? This is at the end of 1 minute because in counter number 3 each transaction takes 1 minute. So 1 minute this is over, this is still on, this is still on, right? And at the end of 2 minutes this is also done and this is also done, right? Because this takes exactly 2 minutes, right? So now can I say there are two counters empty, that is 3 and 2 at the end of 2 minutes, right? So can I say that the transaction number 5 goes to counter number 3 and the transaction number 6 goes to counter number 2, right? Now, this is at the end of 3 minutes, right? Now, at the end of 3 minutes, when transaction number 5 is over, right? At the end of 3 minutes, when transaction number 5 is over, right? This is still on for another 1 minute. Can I say counter number 3 is also empty and counter number 1 is also empty, right? So, if both the counters are empty here, right? So, can I say that the transaction number 7 here, right? The transaction number 7 should go to counter 3 first, right? And the transaction number 8 should go to counter number 1, right? So that is the case here, right? Now after that, at the end of 4 minutes, now 4 transactions are done. At the end of 4 minutes, can I say counter 3 is empty as well as counter 2 is also empty, right? Now if both the counters are empty here, right? So the next two transactions, that is 9 and 10. So first transaction number 9 should go to, I can say, counter number 3, and transaction number 10 should go to counter number 2. So this is at the end of 5 minutes, right? Now at the end of 6th minute, what is going to happen? At the end of the 5th minute, another transaction number 11 is in queue, right? Which is definitely going to go to the counter number 3, right? So this is transaction number 11 and 6 minutes are done, right? Now after 6 minutes, can I say the cycle is going to repeat, right? Can I say the cycle is going to repeat? Isn't it? Why? Because at the end of 6 minutes all the 11 transactions are sorted, right? Now again transaction number 12 is gonna go to counter number 3, transaction number 13 is gonna go here, right? Then again 14 is gonna go here because all the three counters are empty at the end of 6 minutes. So can I say at the end of 6 minutes 3 and 3, these two transactions are done, these three are also done, and these six are also done. So now all the three counters are empty, so I can say it's back to the original state, right? So again the next 11 transactions are gonna go in the same fashion, right? So in a way, can I say that there's a cyclicity of 11 here, right? In a way, there's a cyclicity of 11 here, right? Why? Because after every 11, it is gonna repeat, right? For example, transaction number 12 is same as transaction number 1. It's gonna go here. 13 is gonna go here, which is same as transaction number 2. 14 is gonna here, right? So if you divide transaction number 14, that is 14 by 11, how much is the remainder? Can I say my remainder is 3? So if the remainder is 3, so 14 term should be same as the third term of the cycle. And what is the third term of the cycle? Where is it? It's at the counter number 1 here, right? So similarly, I need to find the 74th term of the cycle here, right? So can I say, because there's a cyclicity of 11 here, right? So if I divide 74 by 11, can I say my remainder is nothing but equal to 8? Why? Because 11 6 is 66, so the remainder has to be 8. And if my remainder is 8 here, so can I say the 74 transaction is same as the 8 transaction, isn't it? And the 8 transaction happens at counter number 1 here, right? You can see here, isn't it? So the 74 transaction will also happen at counter number 1, right? So the answer is option number B, that is 1, right? Let's move ahead to the next one. Now, in this particular question, it says here, if the time taken per transaction in slot S3 on Tuesday and slot S4 on Wednesday is same and equal to T. All right. So time taken per transaction S3 on Tuesday. Okay, so S3 on Tuesday, right? It's per transaction, the time is T. Let's see how many transactions have been done in S3 on Tuesday. So S3 on Tuesday, we have done 51 transactions, right? S3 on Tuesday, 51 transactions. Okay. So if the time taken per transaction is T, right? As per this the question here, right? Then can I say the total time taken will be for the 51 transactions is gonna be 51T. All right. Now it says and S4 on Wednesday. Okay, so S4, that is slot 4 on Wednesday, right? So let's see slot 4 on Wednesday. So slot 4 on Wednesday. So slot 4 on Wednesday, we are doing 71 transactions here, isn't it, as per the table? So here 71 transactions. So the total time that will be consumed is nothing but 71T, right? It says find the value of T for which the ideal time is same for both the slots mentioned. Okay, so the ideal time for slot 3 is same as the ideal time for slot 4 here, right? Now, assume that in any particular slot, the time taken per transaction is same for all the transactions in this slot, right? So they've already told that if the time taken per transaction is equals, right? So that is anyways fine, right? And irrespective of the counter at which the, okay, so it's irrespective of the counter also at which it is taking place. All right, fine. So what do I have to find? I have to figure out the time taken, the ideal time, find the value of T. Okay, so per transaction time is what I'm supposed to find. All right, no worries, right? So if the ideal time is equal for S3 and S4, so let's find the ideal time for S3. So S3 or S4, can I say both the slots are of nothing but 120 minutes, right? And if both the slots are of 120 minutes, and this is the total time spent across all the counters, right? So what is the total time available across all the counters? If there are 5 counters, right? If there are exactly 5 counters and there's a time of 120 minutes. So the total time across 5 counters, can I say 125, 120 to 5, which is nothing but 600 minutes, right? Now at slot 3, let's calculate the ideal time for slot 3 first. So ideal time for slot 3 should be equal to nothing but, can I say 600, which is the total time available, minus 51T, right? That is the time that has gone into the transaction, minus. Now, if you see here, the slot 3 here, right? What is the timing of slot 3? Can I say 12 to 2, right? And we are talking about Tuesday here, right? So on Tuesday, in the slot of 12 to 2, right? Can I say for half an hour, counter number 1, 3, and 5 is empty, right? So can I say if 1, 3, 5 is empty, so can I say 30 minutes of each of the counter is getting wasted, right? And hold on, my bad. This is Tuesday, right? Okay, this is Tuesday. So Tuesday is here, right? Tuesday is here. Anyways, okay. So if Tuesday is here, so can I say, and this is Tuesday, and the other one is Wednesday. All right. So on Tuesday, can I say between 12 to 2 for 15 minutes, right? For 15 minutes, 135 is empty, isn't it? And 1 to 130, right? 1 to 130, can I say 2 and 4 is empty, right? So two of the the slots here are empty. Two of the counters are not working here for half an hour, and three of the counters are not working here for exactly 15 minutes. Why? Because they're not working from 145 to 215, but the time here is of, I can say, 12 to 2, right? The time here is of 12 to 2. So I can say here, two counters are not working for half an hour and three counters are not working for 15 minutes, right? So I can say two counters are not working for half an hour and three counters are not working for 15 minutes. So can I say this is also the time that has to be reduced, right? For because this is also my ideal time, isn't it? So how much do we get from it, right? So I'll get nothing but 600 minus 51T, right? Minus, because it is closed, right? So 60 and 45, that is 105, right? So I can say 600 minus 105 is nothing but 495 minus 51T. All right. Now let's calculate the ideal time for the slot S4. So similarly for slot S4, can I say 600 minus the time that goes into transaction, that is 71T, and minus the time that has been where the counter is closed for the lunch. So on for Wednesday, right? Slot 4, that is on Wednesday. Okay. So the day is Wednesday, I suppose. Let me just confirm once, guys. Yes, slot 4 on Wednesday. Okay. So slot 4 on Wednesday. Let's see Wednesday first. So the time is 2 to 4 p.m. right, for Wednesday, and this is slot 4. Okay, so slot 4, so Wednesday, and 2 to 4 p.m., right? So can I say only for 15 minutes these two counters are empty, right? Only for 15 minutes, because counter number 2 and 4 is closed from 1:45 to 2:15. So can I say 2 and 4 have been closed for only 15 minutes, right? So the time that they have been closed is nothing but exactly two counters are closed, and that too for exactly 15 minutes, right? So I can say 570 minus 71t, right? And this is the ideal time for slot 4, right? And as per the question, the ideal time for slot 4 should be equal to, I can say, the ideal time for slot 3, right? So both of these times should be definitely equal, right? So I'll take a fresh page here now, right? So I can say 495 minus 51t is equal to 570 minus 71t, right? So can I say 71t, if I bring it on this side, minus 51t is equal to 570 minus 495, right? So 570 minus 495, right? So from here I can say that 20t is equal to nothing but 570 minus 495 is, I can say, exactly 75, right? And t should be equal to nothing but 75 upon 20. And remember, we are working in minutes, so this is exactly in minutes. So this is gonna be nothing but, I can say, 20 into 3 is 60, right? So I can simplify this, right? 4 and 15, right? And what is the if you look at the options, right, it's minutes and seconds. Okay, so it's minutes and seconds. So 15 by 4, uh which is 5 ones are 5, 25, 5 fours are, that is, can I say 15 by 4 is nothing but 15 by 4 minutes is, I can say, 3 minutes complete, right? And I'm left with three more, right? So 3 by 4 minutes, which is 3 by 4 minute is basically how many seconds? So I need to multiply by 60 here, right? To convert minutes into seconds, right? So 4 into 15 is 60 and 3 into 15 is 45. So I can say my answer should be nothing but 3 minutes and 45 seconds. So that should be my required answer, right? So again, lot of thing here where chances are of making silly mistake, which is not considered in the lunchtime. People might tend to miss this because this also has to remove, no. So ideal time is the time which is excluding the lunchtime, right? Because here it was clearly mentioned in the question. If you go back here, right? So it says the ideal time is defined as the sum of ideal period, that is the duration for which no transaction takes place during the normal transaction hour at all the counters are open during that slot, right? So the counters have to be open and it's during the normal transaction hour, right? It is exclusive of the lunch break. So I need to remove that time also, right? Because the transaction time goes away and the lunch time also goes away. So the remaining time is your ideal time, right? So people might tend to miss out on the ideal time. And I am supposing that a lot of you who have solved this particular set would have also missed this, right? And if you didn't, that's even better. That's great. That's great. That shows that you're very attentive when you're solving the set, right? And it's very much required, while solving the set, extreme attention. You should be very focused. Your there should be nothing that should be running at the back of your mind, because um CAT is an exam which demands your eyes to be on the screen and your mind is only thinking about what you're solving. It shouldn't run from here to there. What will happen if I'm not able to solve this particular set? What if I get only one set correct? What if I get only two sets correct? What if I make some silly mistakes, right? So a lot of thoughts, will come across your mind. And that is why it is suggested that, you should actually start doing meditation, because meditation or maybe gymming, workout, it helps to calm your mind and you stay focused, right? So any irrelevant thought crossing your mind while you're solving any LRDI set or a sectional test or a full length mock, or during the CAT, you should i- immediately ignore that thought, right? And you should develop that practice from now itself, right? And that is why it is suggested that you write a lot of mocks, because mocks is gonna help you to train your mind to be attentive, to be focused here, isn't it? All right, let's move to the last question now here. So it says on Saturday, if the average number of transactions that took place during the first hour of a slot is 38. Okay. So average number of transactions that took place during the first hour of the slot is 38. Okay. So 38 transactions have taken place average during the first hour of the slot. Okay. So first hour of the slot. Okay. Fine. And not more than 50% of the transactions in any slot took place during the first hour of the slot. Okay. So not more than not more than 50% transaction took place during the first hour. So the number of transaction in the first hour, right? It should not exceed 50%, right? First slot, it should not exceed 50%. All right. No worries, right? Then the maximum number of transactions that took place during the second hour of any slot on Saturday. Okay. So I want to maximize the number of transactions that took place in the second hour of any slot on Saturday. Perfect, perfect. Let's see, let's see. So if I go back here to my table here, right? So on Saturday, what are the number of transactions in each of these slots? It's 86 here, it's 81 here, it's 74 here, it's 79 here, 75 here, and 87, right? So these are the number of transactions on Saturday in each of the given slots here, right? So I can say slot 1, slot 2, slot 3, 86, 81, 70, 74, 86, 81, 74. All right. So slot, so I can say slot 1, right? Slot 2 and slot 3, right? So the number of transaction in each of the slot, right? That is slot 1 and 2 and 3 is 86, 81, and 74 on Saturday. All right. So 86, then I can say 81 and then 74, right? Similarly, I can say for slot 4, slot 5, and slot 6, right? For these of the remaining slots, the number of transactions on Saturday is nothing but, as per the table, 79, 75, and 87. All right, so 79, 75, and 87, right? So let's see. So I can say 79, 75, and 87, right? Now, the question says that not more than 50% of the transaction in any slot took place during the first hour of the slot, right? So maximum number of transactions that can take place during the first hour of the slot here is, can I say 43 here? So this is 43, or I'll just take a different color marker here, right? So slot 1, if this is 43, then this also has to be 43, right? Maximum here is 40.5. So it should be integral value because 50% of 81 is nothing but 40.5. So this should be 40. If this is 40, then this has to be 41, right? Here it is 37, right? So this is also 37 because 50% is the maximum possible transaction, right? 79 half is, I can say, 2 3 is 6 and 19 2 9 is 8, so 39.5. So basically 39 is the maximum possible value here. So 39 is the maximum possible value here, so the number of transaction here can be 40, right? This is 37, so this has to be 38, right? And 87.5, 87, so that is basically 43.5, right? So 43 here, so this has to be 44, right? Now, as per the question, I want to maximize the number of transactions that took place in the second hour of any slot on Saturday, right? So second hour of any slot on Saturday, I hope this is not on my image here. This data here is not coming. Anyways, if it is coming, it's 44, guys, right? This value here is 44. Okay. So what I'm trying to say here is I want to maximize the number of transactions that took place during the second hour of any slot on Saturday, right? So if I want to maximize, so can I say I should focus on the maximum transaction already that is occurring in the second hour of the slots on Saturday, right? On any slot, right? So this is basically seconds, not slot here. I should rather write it here as R, right? First hour and second hour, right? So I should write here R's, first hour and second hour, and these are my slots here, right? So can I say slot 6 second hour already has the maximum value as per the data here, right? Because I have maximized, I've taken the maximum value right now of all the transactions in the first hour. So this is the maximum possible value of the second hour, right? Right, the minimum possible value as of now, isn't it? Now, if because this is maximized, right? So this is already minimized as of now, right? Now, in the worst to worst case scenario, what can happen? It says here 38 transactions took place on an average in the first hour, right? Across all the 6 slots. So can the total number of transaction should be nothing but 38 into 6, right? Because there are 6 slots, so 38 into 6 is nothing but 228, right? Now, because I'm trying to minimize, you understand here, why did I maximize the first transactions of each of these slots, right? Because when I'm trying to, minimize, if I want to maximize the number of transaction of second hour of slot 6, right? So if this has to be maximum, then can I say this value should be minimum? And when will this value be minimum? When rest all other values are maximum, right? So if I'm adding all these maximum values, right? So let's add all these values. How much do we get? 4, 4, 8, 8, 3, 11, 11, 3, 14, 3, 17, that is 170. And 170 plus 10 is 7, and 3 is 180, 189, and 7 is 196, right? So can I say 196 is the total number of transactions in the first hour across slot 1 to slot 5, right? Total number of transaction in the first hour. So can I say least number of transaction in the first hour of the sixth slot, right? The least number of transaction in the first hour of the sixth slot should be nothing but total number of transaction, that is 228, minus the number of transaction across the first five slots, right? Which gives me nothing but 32. So if 32 is the minimum possible value of the number of transaction in the first hour of the sixth slot. So can I see this value here? Second hour of the sixth slot will automatically be maximized, right? So if this is 32 and total number of transactions is 87 in the sixth slot, right? So can I say the number of transaction in the second hour of the sixth slot is nothing but 87 minus 32, that is 55. And that should be my required answer. So with this, we come to the end of our video solution here. If you guys have any doubts, any queries in this particular set at any time stamp, please feel free to comment below. Thank you, everyone.